Hello everyone, my name is Sudhishana Singarao and my matrix number is EL22018. So today we're going to talk about IoT. What is IoT? IoT is the Internet of Things, is a system of interconnected physical device, vehicle and applicants and other items embedded with sensors, software and network connectivity. These objects can collect and exchange data, allowing for improved efficiency, automation and enhanced decision making process. So in IoT, we do have advantage and disadvantage as well. And here we have three advantages. The first one is improve efficiency and accuracy. So it means like automation of process and real-time monitoring help streamline operation, reduce error. So by using IoT, it can reduce your errors. And the second one is automation of daily tasks. Smart home, automated maintenance, and other applications make daily life more convenient. So by using IoT, it may makes your life more convenient because you may check all the result through your mobile phone. The third is enhanced decision making. Data-driven insight and predictive analytics enable better decision making and strategic planning. So it may use it may give you a better strategic planning by using IoT. And the disadvantage of IoT, we have two here. The first one is potential privacy and security risk. The vast amount of data collected by IoT device can be vulnerable to breaches and unauthorized access. So the second one is complexity and potential for failure. Over-reliance on technology and the complexity of managing interconnect devices can lead to operational challenge and system failure. So all the time we couldn't depend on IoT because it may have the system breakdown and the system failures as well. Okay, now let's dive into IoT architecture, which consists of four layers. The first one is sensing layer, network layer, service management layer, and application layer. So the first sensing layer is the physical layer where data is collected from environment through sensor. This sensor can measure various parameters like temperature, humidity, light, and more. It depends on the sensor that you are provided at. So the second is the network layer. This layer is responsible for transmitting the data collected by the sensor to the processing unit. It uses various communication protocols such as Wi-Fi, Bluetooth, and cellular network to ensure the data reaches its destination securely and efficiently. The third is service management layer. In this layer, the data received from the network layer is processed by analysis. It involves data management, analysis, and decision making based on the insight gathered. This is where data gets transformed into more useful information. And the fourth one is application layer. The final layer where the data proceed is utilized to provide service and end user. Application in smart home, health monitoring, industrial automation, and many other areas use this data to offer valuable services, improving efficiency and enhancing user experience. Now let's go into the IoT protocols. To make all this possible, IoT relies on several key protocols for communication. So we have four protocols at here. The first one is MQTT, the second is COAP, third is HTTP, and the fourth is DDS. So the first one is MQTT. MQTT means Message Queuing Telemetry Transport. MQTT is lightweight messaging protocol designed for small sensor and mobile device. It ideal for low bandwidth, high latency or unreliable networks. MQTT works on publish subscribe model, making it highly efficient and scalable. Second is the COAP. COAP is Constrained Application Protocol. COAP is designed for concentrated device and network, often found in IoT application. It allows device to communicate efficiently using simple, lightweight protocol. COAP is based on the rest of models similar to HTTP but optimized to IoT environments. The third one is HTTP. HTTP means Hypertext Transfer Protocol. HTTP is the foundation of data communication on web and is widely used in IoT as well. So while it is more resources intensive compared to MQTT and COAP, it is widespread adoption to familiarity make it common choice for many IoT applications, especially those requiring for web integration. The fourth one is DDS. DDS we call as a data distribution service. DDS is designed for real-time, high performance and scalable data communication. It is used in systems where reliability and speed are critical, such as industrial automation and robotic. So it mostly will use in industrial automation and robotic. DDS provides a flexible and robust framework for managing complex data exchange. Thank you.
Good day everyone, my name is Sri and my entry number is EL22017. In this slide, we are going to see about the 11 IoT technologies parameter information. The technical information is stated here, and now I'm going to talk about the advantage and the disadvantage. First one is Wi-Fi. As you all can see, the frequency is 2.5 GHz to 5 GHz. The range is up to 100 meter and the data rate is from 54 megabps to 1 gigabps. It can be used in home networking and an industrial application. The advantage of Wi-Fi is it has high data rate and widespread adoption, and the disadvantage is it has high power consumption and also has limited coverage. Next is Bluetooth. The technical information are quite same with Wi-Fi, but it has a lower data rate than Wi-Fi, which is 1 Mbps. Bluetooth comes in wearable products such as AirPod, smartwatch, and so on. It has low power consumption with widespread integration in smartphone, but it is not suitable for file transfer. Next is Zigbee. Zigbee is a wireless protocol used by everything from IoT devices such as light bulbs, sockets, plugs, motion sensor, and other home automation devices to smart energy, and also electrical vehicle charging and industrial building controls. It has lower power consumption with high security, but it works in limited range with lower data rate. Next is LoRaWAN. It is described as a low power wide area networking protocol designed to wirelessly connect battery operated things to the internet. It can be used to control air conditioner, heating system, street light, security, and other IoT applications. Next is Sigfox. Sigfox is an inexpensive, reliable, low power solution to connect sensors and devices. It is mostly used in M2M application, which is machine-to-machine communication for remote monitoring. Next is Near Field Communication (NFC). It is a set of short-range wireless technologies. NFC lets you share small payloads of data between an NFC tag and an Android powered device, or between two Android powered devices. Next is Z-Wave. It is a mesh network using low energy radio waves to communicate from device to device, allowing for wireless control of smart home devices such as smart light, security system, thermostat, sensors, smart door locks, and garage door openers. Next is Thread. It is a low power and low latency wireless mesh networking protocol built using open and proven standards. Connects your small smart devices from motion sensor to door locks, and also offers a better, more efficient way for them to work together. Next is IPv6 over low power wireless personal area network. It's a low powerless mesh network where every node has its own IPv6 address. This allows the node to connect directly with the internet using open standard. It is used in home automation, smart agriculture techniques, and industrial monitoring. Next is Dash 7. It is an open source active RFID standard for wireless sensor and actuator network. It used for tracking, mainly in supply chain management. Next is Narrowband Internet of Things (NB-IoT). It's a standards-based low-power wide area technology developed to enable a wide range of new IoT devices and services. The examples include smart meters such as electricity, heat, water, and gas meters, as well as asset tracking applications such as monitoring containers or pallets. Next is RFID, radio frequency identification. It uses radio waves to identify people or objects. This technology is widely used for proximity detection, vicinity detection, tracking, authentication, and access control. Next is 5G. 5G delivers more data faster and more securely, and this will be used to connect a new range of IoT devices and applications. The last one is LTEM, Long-Term Evaluation Machine Type Communication. It's a type of low-power wide area network radio communication technology standard developed by 3GPP for machine-to-machine and Internet of Things. It also works similarly as Sigfox. Now let's go to question 2. One of the IoT applications that has been launched in Malaysia is the Smart Traffic Management System by the Malaysian government. This system uses IoT devices such as sensors and cameras installed at various traffic lights and intersections to monitor traffic flow and adjust the timing of traffic lights accordingly. The system also uses data analytics to predict traffic congestion and provide real-time traffic updates to drivers. The system is connected to a central control center where all the data is collected and analyzed.
Good day, madam. My name is Arpudraj, son of Pushpanathan. My metric number is EL22078. Today, I want to explain about four layers of IoT architecture. The first layer is sensing or device layer. The function of device layer is this is the layer where the sensors and cameras are installed at various traffic lights and intersection. The second is network layer. This layer is responsible for transmitting the data collected by the sensors to the central control center. The third layer is service management layer. This layer is where the data is collected, stored, and analyzed. It also manages the service provided by the IoT system. The last layer is application layer. The function of application layer is this is the layer where the end users interact with the system. In this case, it would be the drivers who receive real-time traffic updates. The IoT protocol selected for this system is MQTT, which is Message Queuing Telemetry Transport. This protocol was chosen because it is lightweight, open, simple, and designed for constrained device and low bandwidth, high latency networks. It also provides reliable message delivery at various level of quality of service, which is called QoS. There are three advantages of using MQTT protocol. The first advantage is it's designed for low bandwidth, high latency networks, making it suitable for IoT applications. The second advantage is it's provide reliable message delivery at various level of QoS. The third advantage is it is lightweight and consumes less power, which is crucial for IoT device. They have got some disadvantages of using MQTT protocol. The first disadvantage is it lacks built-in security features, which can be a concern for IoT applications. The second disadvantage is it requires a broker to function, which can be a single point of failure. Thank you. Since its launch, the Smart Traffic Management System has made significant improvements in managing traffic congestion in Malaysia. It is reduced the average travel time for commuters and improved the overall traffic flow. The system has also helped in reducing carbon emission by minimizing idle time at traffic lights. The real-time traffic updates provided by the system have also helped drivers in planning their routes more efficiently.